Okay. Hence the reason I'm going to take it kind of fast. Okay. All right. So in 1774, Joseph Priestley performed a really famous chemical reaction that led to the discovery of oxygen. He took a deep red powder, which is mercury 2 oxide, and he decomposed it by heating it. And it formed mercury, liquid mercury, which is silver, and then oxygen gas. Obviously, since we went from a deep red powder to a silvery liquid, that is an unexpected color change, and that would be a form of evidence that a chemical reaction took place. You've got two different types of ways for representing chemical equations. You have a word equation, and then you have a formula equation, okay, which is just a balanced equation with the chemical formulas. Now, sometimes formula equations will be called molecular equations. So they are the same thing. Remember, the reactants are the starting substances on the left-hand side of the equation, and then the new substances that you form are the products, and those are on the right-hand side of the equation. States of matter are sometimes included after the substances. So you'll notice at the top of the next page that they have gone over what solid, liquid, and gas is. I'm just going to point out that AQ stands for aqueous. That means that that particular substance is dissolved in water. This figure shows you the reaction that I talked about on the previous page, where we have the deep red powder, mercury 2 oxide, being heated, decomposing into the silvery liquid mercury, and then oxygen gas is leaving this open test tube, so that means the mass would be decreasing. There are different forms of evidence that a chemical reaction has taken place. Some of those examples that you should definitely know are if it absorbs or releases heat. If it absorbs heat, it will feel cooler to you, okay? Sometimes light will be emitted as well. An unexpected color change. If you combine two liquids and they are yellow and blue and you make green, that is expected, okay? Unexpected would be like what we saw here with the red turning into the silver, okay? Something else would be evolution of gas. This simply means that a gas is produced. You would see bubbles on the side of a container if you had solutions that were mixed. Also, if you mix two solutions and you form a solid, that means you formed a precipitate. Typically, it will look cloudy at first. If you let it settle over time, it will sink to the bottom. Precipitates can be in different colors, yellow, black, gray, white, just depends. And then we're going to skip the quick check. Let's talk about balancing equations for a second. So balancing equations is because we need to follow something called the law of conservation of mass. Antoine Lavoisier is the one that is formally credited with coming up with the law of conservation of mass. And the reason is because he loved to measure the volumes and masses of the chemicals that he worked with. Okay. If you take a look at the next page, we will be placing coefficients in front of substances to follow the law of conservation of mass. This is known as balancing equations. So balancing a chemical equation requires placing coefficients in front, not as subscripts on chemical formulas, and those numbers make sure that we have the same number of each type of atom on the reactant and the product side, okay? Now, you need to make sure that your coefficients are simplified, meaning if they are all divisible by the same number, you must simplify them. So if everything is divisible by 2, for example, then you want to make sure that you show that. Let's go ahead and skip this stuff. I'm going to do one example, okay? Let's go right here to these practice problems. Let's take a look at practice problem number 3, okay? Here we've got calcium metal reacting in a solution of nickel 3 sulfate to form calcium sulfate solution in nickel metal. If they tell you what the states of matter are, or you can deduce them from what is given, then you typically include them. anytime they say that you have a metal, that means it's a solid. So calcium metal would be calcium with a little S in parentheses after it, and it is being placed in an aqueous solution of nickel 3 sulfate. So nickel 3 is Ni plus 3, sulfate is SO4 minus 2. That means the chemical formula is Ni2 with SO4 in parentheses and a 3 on the outside. Aqueous solution means it's dissolved in water, so you put an AQ after it. It's forming calcium sulfate solution. Calcium is Ca plus 2. Sulfate is SO4 minus 2. So you're going to get CaSO4 with the AQ after it. And then you form nickel metal. So that means this would be Ni with a little S after it. Now, remember, when we are balancing things, you have to balance polyatomic ions as groups, right? So I've got 3 SO4s on the left. So you'll put a 3 on the right to balance the SO4. Then you've got 3 calciums. So you're going to put a 3 over on the left-hand side to balance the calcium. Then you've got 2 nickels. So we're going to put a 2 here to balance the nickel. 3, 1, 3, 2 would be the balanced equation. Any questions on section 4.1?